We will be creating a real-time inferencing service. After training a predictive model, we can deploy it as a real-time service that clients can use to get predictions from new data. We have already created a workspace, a machine learning workspace with the subscription ID as this, the resource group as RSAG, and the workspace name as WSAG. The config.json of the workspace is already there for us. So what we will do is that we will connect to it. Before that, we will just show you actually the workspace that is created. While it is coming up, let's run this cell and connect to the workspace. So it is ready to use with the workspace WSAG. And if I go here, if I go to machine learning, and if I go to this and which I launch the studio, we can see the workspace is already there for us. In the workspace, there is a config.json file which we have used to connect. Next, what we will do is that train and register a model. This is the same code that we have used before. Here we are getting the experiment in our workspace. We are creating the experiment. We have started logging and we are loading the diabetes data set. We are separating the features and the labels. So these are the features which is denoted by X, and this is a Y, which is a target value. We split the data into the training set and the test set using train test split. We train a decision model using the decision tree classifier of the scikit-learn library, which is here, sklearn.tree, and then we predict using model.predict, calculate the accuracy and also log the accuracy using the run object. Similarly, we calculate the AUC or the area under the curve by predicting the probability and also log it. We save the trained model and upload the model into the workspace. We complete the run and we also register the model. So let's run it. So while it is running, what we will see here is that when it is registered, it will appear in the models. So it is still running. Therefore, we do not see here the experiment is still running. It is complete. Since it is complete, then we can see the registration of the model here. The model is registered. You can see that it is inline training. So then what we will do is that we deploy the model as a web service. To deploy the model as a web service, let's see the models which are registered there. We are just using the API. We are getting what are the models from the model list, and we are getting the tags, and the tag is training context inline training, which you can see it here. Moreover, you can see that these are the metrics which are there, AUC and accuracy, which also you can see from the model. If you go here, the properties are there for the model. Moreover, what you will see is that you can get the model by querying the workspace models. So for that, what we are going to do is that we are going to create a web service for this model. We are creating and we are setting the path of the score diabetes.py. And in the script file, what we are going to do is that we are writing to the script file is that it has got two parts, the init and the run. The init is run when the service is loaded. In this, what we are doing is that we are getting the model, the diabetes model, and we are loading the model when the service is loaded. And then in the run, when the request is received, we are predicting using model.predict. And then we are dumping it as a JSON. So this is a script.py. So what is the takeaway from this? The takeaway is that the script consists of two main methods, the init and the run. What is the init? The init will give you to load the model, And what is the run? The run is called when a request is received. The request is received with an input data. Here we are receiving the input data as a numpy array, and then we are predicting it with model.predict, and then we are getting the classes, and we are using JSON to display the result. The inference would also require an environment file. We write the environment file also. We are using the write file, environment file, and the name is inference env, and the dependencies are Python, scikit-learn, pip, and Azure ML defaults. So this is all done in the YML file, and once this is done, we will then deploy the service in a container. What container we will use? We will use an Azure Container Instance. For that, what we are doing is that we are configuring the scoring environment. For the scoring environment, we are using the inference config, which would require the runtime, which is Python. The entry script is a script file which we have described above, which we will see here, and also the environment file which contains the environment. So this is the inference config. Once the inference config is done, what we will do is that we will use the ACI web service to deploy. And the deploy configuration is with a CPU core of 1 and a memory GB of 1. The service name is diabetes service. We then use the model to deploy, and let's run it. This will take some time. So while it is doing it, we will come back after it is done. So if you are doing it or following along with me, please note that this will take some time. Thank you. I will come back after it is done. I am back again, and we see that the web service has been deployed successfully. If we go to the resource group, you will find that the container instance has been created automatically by the deployment, and also we see the container registry is also present by the, and it has been created by the program. So all done, and also we check in the models, uh, in the workspace that the endpoints it is also present. Let it load. So we have the diabetes service, the condition is healthy, and it is ready to go. Now what we do is that the next step is that we use the web service. How do we use the web service? Whenever you try to use a web service, you have to give it some input. So what is the input that we are giving? We are giving the features in the form of a list, and then it is being converted into an JSON document by using the JSON dumps, and then we are using the service, and we are using service.run with the input data, and we find that we can get the predictions, and from there we can get the predicted classes. So here the predicted class is diabetic. Similarly, we can also send multiple patient observations to the service. Note here that you are sending this as the first observation separated by a comma. Another observation is being passed. Here also you are converting it into an JSON document, and you are passing to the web service, and you are getting the predicted classes. Similarly here you will find the predicted classes also here, but here we are iterating so that we can get the classes. Now what we can do is that we can get the endpoint scoring URI, that is the HTTP path. Let us see whether we can also get the HTTP path from here. I am not. Yes, you can also get the REST endpoint from here. It also gives some code also how you can use it. So this is a code. So we have used it in code using the HTTP scoring URI, and the difference is that we are using the requests object to post it to the endpoint with the input JSON and the headers as application/JSON. we get the same service. Ultimately, when we do not need the service, it is better to delete it, so we will delete the service. Hope you liked the lecture. Thank you. Bye. So, what did we do in this? We had created a real time service and we had deployed it successfully into the Azure machine learning workspace. Thank you.